Welcome to the course on microwave and antennas. In this lecture, we will learn about mode curve analysis. In the previous section, we have learned about the klystron oscillator modes. Remember, there are four major parameters or input variables which we need to consider. Let me write it down. Beam voltage, acceleration grid voltage, cavity field, reflector voltage. So the beam voltage is coming from this side. The acceleration voltage is also coming from this side, and this is the cavity field, and this is the reflector voltage. There are two major outputs that we are interested in from a klystron oscillator. What are the two outputs? Number one, frequency of microwave signal. Power of microwave signal. These are the two outputs that we are interested in. If you want to change the frequency of a microwave signal, which basically means that we are saying the cavity has to resonate at this new frequency. So you have to change the cavity design to get a new frequency. So frequency depends on cavity design. This is similar to LC tank circuit, where if you want to change the resonant frequency, you have to change the value of L and C. In the previous session, we assumed following. Let me erase all this. In the previous section, we assumed that electron beam is a constant voltage. Accelerating grid voltage is also constant voltage, and reflecting electrode voltage is also a constant voltage, and thus there is a continuous stream of electrons coming into the tube and uniformly accelerated until the point where AC voltage due to cavity resonance is applied on the electrons. That is, this is the resonance. Now let us understand the mode curves, but before that let us visit and revisit and look at the modes. So we have seen this picture before. We know what modes are and what is the equation. The equation is and so on. These different values of small letter n in relation to different values of reflector voltage are called as modes of the klystron oscillator. So this small letter n in relationship to reflector voltage are called as modes of the reflex klystron oscillator. Here, small letter n represents full cycles of the resonating frequency. That is, this is a full cycle. One cycle. This is one cycle. N represents the full cycles, and capital N represents fractional cycles. So if n is equal to, example, if n is equal to 0, then n is equal to 3 by 4. So this is a fractional cycle. This is not a full cycle. And this is what we need to create bunching. Mode curves are arrived by keeping cavity dimensions constant. So if cavity dimensions are constant, this implies frequency is constant.